All right, function folks, back to part two of this uh, weird three-thing lesson, three sections or part sections or whatever. Before we go on with the last example, I want to mention something that the textbook, uh, how they do things for transformations is, remember, they come up with these formulas for points where x and y was a point on the original function. So I mean, those are the ones that we could fit on our graph. That was on the original black function there. And then what did they turn into on the new function? Well, they did, okay, well, what did these stretches and squishes do to the points? Well, a horizontal expansion factor 2, did this, and vertical expansion, and then move left. Well, we just subtracted 6 from the x coordinate. And then that allowed me to come up with what the points are on the green graph straight off. So the advantage would be that you could draw the graph of the end function pretty quickly. And that's the textbook. Again, I like doing this because I'm kind of a graphing person. I like seeing what each of the pieces does and so on. All right, back to now on to the last example. We're just asked to find the x-intercepts of these functions. Now notice that now we could graph these. We see this is the parent function of the cubic graph, moved left 4 and up 9, and a vertical squish of factor 1/3. Again, this calculation, finding the x-intercept, is nothing new for us. We've found x-intercepts of parabolas in grade 10, lines in grade 9. This isn't hard. Maybe it's different just because we have never done it for cubic functions. And we'll see that, yeah, it's a little bit of a change in calculation, but not much. For the x-intercept, remember that's when y equals 0. So I'm solving this equation for y equals 0, right? Well, subtract, I just want to solve for x, subtract 9 from both sides, multiply by 3, and then how do I undo a cubic? Well, it's cube root. And I can do the cube root of 27, negative 27 in my head. Something times itself 3 times, that gives me negative 27. Negative 3 times negative 3 times negative 3 gives me negative 27. And we'll show you, if you're not sure what that value would be, how to put that into your calculator. But then I've got negative 3 is equal to x minus 4. X is minus 7. And so notice that means on this function it has the x-intercept, and only one of them, of minus 7. Does that make sense? Well, and I'm not going to do this for all of them, but I think of the normal graph moved, now can I do this without moving the whole thing? Yes. Moved left 4 and up 9 and then squished. Could I convince you that that would be an x-intercept of minus 7? Yeah, probably I could convince you of that, and that's the calculation there. Onwards and upwards. This next calculation is, again, the y-intercept of the x-intercept is when y is 0. And so now I'm solving for x here, minus 7 on this side. Plain old algebra calculation, divide by negative 4. Negative 7 divided by negative 4 is going to give me 7/4. Negative divided by negative is positive. And I'm going to leave it like that. Now, when I take the fourth root of this, notice the fourth root of this doesn't go evenly, so I'm going to need to use a calculator. But I also want to remind you of something that came up in grade 10, that I'm not going to use the x, I'm going to use, let's say, a squared equals 25, that when I took the square root of this, there's actually 2 values of a that work. It's the positive and negative square root of 25, which is the positive and negative square root of 5, because negative 5 squared is 25 and positive 5 squared. So when I take a positive, the root of an even degree, degree 2, degree 4, degree 6, that I'm going to get two solutions, a positive one and a negative one, because then it ends up being, even if it's a negative fourth root of 7/4, that it's going to be still a solution. Over here I didn't have to worry about that because there wasn't a second solution, because I could have a negative answer. And now notice here, add 3 to both sides. I got 3 plus or minus the fourth root, which I don't know what that is, of 7/4. Now I need to put that into my calculator. Let me get my graphing calculator fired up, and I'll be back with you in just a moment. Okay, there she is. Isn't she beautiful? There's my graphing calculator. And I'm going to try and put in this exactly as it appears. I'm going to try this. So I go 3 plus, now I've got to put in the fourth root. The fourth root, notice I don't have a fourth root button. You won't have a fourth root button. But what I do have is under my math button, and you'll have this button on your calculator, this xth root. The xth root gives you the root of any root that you want. Now notice that I would have to tell it that I want the fourth root. So I put in the 4 as the fourth root, then I hit my fourth root button, which is this one. And notice it's kind of like the 4 takes the place of the root, and then I want to put in 7/4. 7 divided by 4. Notice I use brackets, so it's going to take the fourth root of the entire thing. I press enter, and I get my answer of 4.15 about. For you on your calculator, that xth root button probably looks something like this. So you'd put in 3 plus 4, then that button, and it might be a second function. You might have to press second function to get to that button, and then bracket 7 divided by 4, something like that. I've got the other old school calculator here, and notice it's got a cube root button, but not a fourth root button. See, there's that button that I'm talking about. Now this one's backwards. This is an old school one. So what I have to do, I have to go 3 plus, and then I have to put in what I need to take the root of first. So I'm going to take the root of 7 divided by 4, and then I want to do the fourth root of that. That's this, the 4. And there it is. See, it's backwards on the old school calculator. I put the root in last. And so if you've got a trouble with your calculator, don't be afraid to ask. Now these old school calculators aren't as good because I can't see what I just put in, and I can't change it. So I'm going to go back to the good old graphing calculator. Remember, these are sitting at the front for you to use in class, and of course, hopefully you downloaded the version that you have one in front of you as well. Notice I just press second enter to get the last entry. Then I can change that to a minus, and then I get the other root. And I've forgotten it already. Great memory there, Resto. 1.85. And so those are the two roots. And notice that kind of makes sense, because if I were to think of this function, right, it's a boxy parabola that's been moved, that's been flipped, first of all. Flip, and moved right 3, up 7. And could I convince you that that's 1.85 and 4.15? You betcha I could. All right, well, let's keep going. And again, remember, if you're having trouble with your calculator, please ask in class. That's why we have, it's an advantage with these flipped classrooms. We got lots of time to spend one-on-one doing these sorts of things. Notice this would be a pain to graph, this one, C, because I'd have to factor it out, and stretches all over the place is kind of a hassle. But let's just calculate the X-intercepts. That's all we were asked to do, so let's do it. Now I subtract 1 from both sides. Divide by 4, right? I can't take the fourth root yet because that 4 is in the way. just solving. I'm going to put it all into my calculator at the end. Fourth root. Oh, some of you are sensing some trouble, and this is trouble, isn't it? I can't take the square root of a negative. Can I take the, up here I could take the cube root. Can I take the fourth root of a negative? No. I can't do this. Right? Because there's no number that multiplied by itself is going to give me the fourth root. Right? So that, what does this mean? There's no solutions to this. So that means this graph, y equals whatever that was equal to, y equals f of x, has no x-intercepts. Is that possible? Well, let's have a think. I've got a graph that's a stretched boxy parabola. What's been done to it? It's been moved left a little bit. It's been stretched, right, by factor 4, and squished horizontally, but I'm just worried about the moves now. Moved left and up. Left and up. What are the x-intercepts? No x-intercepts. This makes complete sense that I would have an error, that I wouldn't be able to take the fourth root of a negative number, and it makes sense graphically. All right, that's it. Long video today. Lots of homework. Big day. Good luck with it in class, folks.